Hey guys, we're going to be doing mathematics now, and we're going to start off with the simple stuff, expansion, and I think I might be covering factorization in this video as well, but I'm not sure. So expansion is quite easy, and you just you just have to use your common sense while using it, and you have to pay attention. You do not miss out any of the terms. For example, if there's this a b plus c, this between the brackets over here is always multiplication, so make sure you remember that. So then you multiply a with b, so it becomes ab, and you multiply a plus c, but there's a addition sign over here, so it becomes, you add those two terms, so it becomes ab plus ac. So if you take a real example, it looks something like this. If you have 2 4 plus 5, one problem in this is you always have to solve the sum between the brackets first, but since you do not know what these terms are, this is how you factorize. So probably this is not a very good example, so let's just erase that. Sorry about that. Oh, right. So let's say it's x, which is like the common algebra term. So it's x 2 plus y. So since you don't know what y is, you just have to expand the whole term. So it becomes x times 2, which is 2x, plus y times x, which is xy. This is what it will become. Now this is the easy stuff, and now we get to, and this is called the distributive law because you're distributing the b and c in order to multiply it for this. Now we take two brackets with two terms each, so it's a plus b, a I mean c plus d. So as you can see, there are four terms in total, and you have to make sure you multiply a with these two, b with these two. So what you do is first do AC, and since there's a addition sign on both of these, you do AC plus AD plus BC plus BD, and then this is a fully expanded term. So yeah, expansion in this is quite easy. And now we get to difference of two squares. So you have two squares, which is a plus b and a minus b. Now there's a formula for this, but if you see, you expand both of them, so it's a times a, right, which is a squared. Then there is a times minus b, so that is minus ab. And there's b times a, which is plus ab. And then there's b times minus b, which is minus b squared. So as you see, these two terms in the middle cancel each other out because it's minus and plus, and they're the same term. So in the end, it becomes a square minus b square, right? So this is the formula. So if you have any terms that are like this, you can automatically put them like that. So if you have x plus y and x minus y, then it will become x square minus y square, because the middle term cancels each other out, as you saw over here. And now we get to perfect square expansion, which is a plus b in brackets squared. So it's a plus b squared. Now one way to do this is make it a plus b bracket a plus b, and then you expand it like we did over here. But we don't want to do that because there's a much easier way to do it. And as both of these terms are equal, there's a really quick formula which you can use. You just make the term, just do this, a square plus 2ab plus b square. This is the formula used to solve something like this. So let's say you have 2x plus 1, 2x plus 1 squared. What you do is you do 2x squared plus 2 2x times, or we should put a dot, times 1 plus 1 squared. And this is quite easy to solve now, as it will become 4x squared plus 4x plus 1. Now you multiply 2x by 2x, so it will become 4x squared, and you multiply 2 by 2x times 1, and 2x times 1, anything times 1 is the number itself, so that'll become 4x as well. Sorry about that, 4x, and 1 squared is 1. So here you have a very nice and simple answer. This is called perfect square expansion. Now 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 there's also something called factorization. So practically, if you want to reach from a fully expanded term to its factorized form, and this can be very useful if you want to simplify the formula. So instead of having a lot of numbers in an equation, you can just factorize it like this and then expand it once you get your answer. So that can be extremely useful. I'll be doing it right over here. So perfect factorization I'll be talking about in another video.